Good morning. Good morning.
Good morning, sir.
Good morning, sir.
Morning, sir.
Morning. Shall we start then? Is everybody in? Shall we start? Okay, only 34 people have logged on. Right. We are in the process of comparing the mean of different treatment. So that we will do after saying that our treatment is significant, right? Once the treatment is significant, then we will go for mean separation. It is called as mean separation technique. So here we have learned how we can do the mean separation using different techniques. 4 techniques are available: least difference, Duncan multiple range test, Donut test, and Turkey test. So we said whenever or wherever we use this different, we cannot use everything at once. There are some purpose to use it, right? So this is what we said, the selection of mean separation procedure will have to go according to our objective. Suppose if you have small number of treatment to be compared, right, then we can use least significant difference, LSD. If you have large number of treatments to be compared, then we can use DMRT or Turkey student night test. So DMRT or TSRT. So if you have large number of treatment to be compared and all possible treatment to compare. Then if you want to compare with a specific one means it is the control. If you want to compare with the control, then we use the Donut test. Donut test, it is used to compare with the control. Right, now let's talk about group comparison. What do you mean by group comparison? Today we will start with a group comparison. Last week we have seen only the pairwise comparison. So suppose let's say I have 5 treatment, T1, T2, T3, T4, T5. So if I want to compare T1 versus T2, T1 versus T3, T1 versus T4, T1 versus T5. So how does it look like? What kind of comparison that we can make if I want to compare T1 versus T2, T1 versus T3, T1 versus T4, T1 versus T5? So what is the best technique I can apply? Among the 4 techniques that we have learned, what is the best technique? Anyone? So you see here, T1 is look like a control. T1 is a look like a control. So we are comparing control versus rest. So what is the technique that we can use? Mean separation technique, control versus rest. What is that? Anyone? Donut.
Donut test.
We'll have to use Donut. Right? We'll have to use the Donut test. Right? So if I want to compare all possible, right, then we can use either Duncan or Turkey test. Suppose if I have only 3 treatment, if I have only 3 treatment or 4 treatment, I can use the technique called LSD, least significant. Right, now I have a situation where T1, T2, T3, T4, T5. I have 5 treatments. I have 5 treatments, T1, T2, T3, T4, T5. Right? Let's say 100% organic fertilizer. I say this treatment is 100% organic fertilizer, right? This treatment is with nitrogen inorganic, right? Right. Inorganic, right? Where we put 50% nitrogen. Inorganic, nitrogen. Inorganic again, 100% nitrogen. This is again inorganic, 50% phosphorus. This is inorganic, 100% phosphorus. Is it clear? The board is clear. T1 is totally inorganic, sorry, organic fertilizer, 100% organic. Here this is 50%. I mean, it is inorganic, but it is 50% nitrogen. The rest 50% other material. Doesn't matter. Here this is inorganic, 100% nitrogen. Here it is inorganic, 50% phosphorus. Here it is inorganic, 100% phosphorus. Right, now I am going to talk about introducing a term. Earlier you see, at each time we are comparing one treatment with another. One treatment with the another, one treatment with another, one treatment with another. Always we compare 2 treatments at a time. 2 treatments at a time. Now we are going to talk about group comparison. Group comparison. What do you mean by group? Let's say my objective is to see organic fertilizer versus organic fertilizer versus inorganic fertilizer. My objective is to see organic fertilizer versus inorganic fertilizer in this experiment. Right, tell me which treatment is with organic and which treatments are with inorganic. Can you tell me which treatment is with organic, which is with inorganic? Yeah? Which treatment is with organic, which is with inorganic? Organic, T1 is the organic one. What about T2, T3, T4, T5? All the rest 4 treatments are with inorganic. So my objective is organic versus inorganic. So what I want to say, T1 versus T2 plus T3 plus T4 plus T5. Right? So the average, average of T1 versus the average of T2, T3, T4, T5. Is it clear? So this is what we call as group comparison. Earlier we compared only two treatments, T1 versus T2. Here we are comparing a group. This is a group, isn't it? Average of a group. Average of a group. As an example. Right? Let's take another example. I take 5 variety. V1, Kaji variety. V1, V2, V3, V4, V5. Right? Let's say these three are new varieties, newly improved varieties, Kaji varieties, newly improved varieties. These varieties are old improved varieties. Old improved varieties. These two are old improved varieties. These three are newly improved varieties. My objective is to compare old improved variety versus new improved variety. So my objective is to differentiate or to see the performance between old improved variety and new improved variety. So what should I do? The average of old improved variety versus average of new improved variety. The comparison between average of old improved variety and new improved variety. So you see, so now we are comparing this versus this. It is a group comparison. So this is what we are going to learn today, group comparison. Is it clear? Is it clear? Okay. Group comparison. So we are going to compare groups. At a time we consider groups. So you see, this is one setup. T1 versus the rest. Here V1, V2 versus the rest. So we can have any kind of comparison as such for the group comparison. Keep in mind, this group comparison is called as orthogonal comparison. We will come to that when we do the lectures. Is it clear? So now we are going to talk about this group comparison. Earlier, in previous case, we compared not the group but individuals. Right. So it is called as group comparison. This comparison is called as orthogonal contrast. I will talk about contrast, what it is. For example, this is one contrast. This is called as contrast. This is called as contrast. This is another contrast. So we have different contrast. Okay. Right. Orthogonal mean, maybe you might have heard about this term orthogonal. It is at right angle. So if you have, this is at a right angle. So this is y is orthogonal to x. All right. Orthogonal mean, if you have a right angle between two axes as an example, so this is called as orthogonal, 90 degrees, right? Let's say A, this is B. This is not 90 degree, this is less than 90 degree, right? This angle is less than 90 degree. So A is not orthogonal to B. So that is what we call as orthogonal concept. Right. So orthogonal means perpendicular or right angle angles. The word perpendicular, however, is usually reserved for the two-dimensional cases. Orthogonal is, usually we can consider only two-dimensional cases. If you have 3-dimensional, 4-dimensional, it is very difficult to express what is orthogonal. Orthogonal is a generalization of perpendicular to high dimensions. So this is what we already said. So further, this is what I said. This is these two axes are orthogonal. This is a 2-dimensional one, no problem. But if you have 3, 4, 5-dimensional, then very difficult to draw a orthogonal diagram, right? So what do you mean by orthogonal contrast? Look at this x value and the y value. The coordinate of x value is 0 and 1. The coordinate of x value 1 and 0. The coordinate of y value is 0 and 1. When you want to say these two vectors are orthogonal, their products should be equal to 0. What do you mean by product? They are multiplication. That means if you multiply 1 with 0 plus 0 with 1, right, then it should be equal to 0. So that means you multiply this 1 with this 0, that is given there, right? Then you have multiplication 0 with 1, right? That is given there. If you look at the addition of these two products, then that is equal to 0. So this is called as orthogonal. So 0 multiplied by 1 plus 1 multiplied by 0, which is 0, it is called as orthogonal, right? So here, this is orthogonal. Look at the second example. We want to multiply this 0.5 with 1 plus this 0.5 with 0. So what is the answer? If you multiply 0.5 with 0 and 0.5 with 1, add it up, right? So here in the same way we can say 1 multiplied by 0.5, right? Then 0 multiplied by 0.5. You add these two values. If it is not giving a value 0, this is not equal to 0. This is not equal to 0, so we call it as non-orthogonal. So it is called as non-orthogonal, right? So this is how we express the orthogonality. Once we go through the text, you will understand. In the other techniques of mean separation, the LSD, DMRT, Donut, Duncan, Turkey are used for simple comparison. As I said, it is used for pairwise comparison. But it is often encountered comparison that involve more than two means in one comparison. So this is what I said, more than two means in one comparison. So for example, here, the variety or even the fertilizer, it is getting the average of more than two means. So that is why we say comparison of group. Comparison of this nature can effectively be done using the orthogonal contrast. So we'll have to use orthogonal contrast to come up with the proper separation or mean separation technique. The contrast can be defined as summation of AI yi bar. I will explain that, right? Where AI is the coefficient of ith mean, yi bar is the coefficient of the, AI is the coefficient of ith mean, which is given as yi bar. For instance, the contrast y1 bar minus y2 bar is the form of defined above with A is 1, because look at what is the coefficient for A1 is the coefficient which is given for Y1 bar. So here the coefficient is 1 because no value is there. So here also there is a coefficient which is minus 1. The A2 coefficient is minus 1. So addition of these two coefficients should give a value 0. Right? Right. Now let's take simply this example to talk about this coefficient. I'll take this variety. The same example. Variety 1, variety 2, variety 3, variety 4, variety 5. So my first contrast, I will put it as contrast 1. All right. My objective is V1 plus V2 divided by 2 versus V3 plus V4 plus V5 divided by. That is my first objective. I want to compare new improved variety with old improved variety. So how I can give the coefficient? Suppose, let's say, if I have the coefficient here for V1, half, here again half. So this is the positive value. Here they should have negative value as a coefficient, minus 1 over 3, minus 1 over 3, minus 1 over 3. Look at very carefully the board, very carefully. So here the coefficients I have given for each variety, V1, V2, V3, V4, V5. V2, V3, V3, V4, V5 coming into one group, V1 and V2 coming into another group, right? So add the values of this. What is the value if you add all these? Half plus minus 1/3 plus minus 1/3 plus minus 1/3. What is the total value? If you add all the value, what is the total value? Half plus minus 1/3 plus minus 1/3 plus minus 1/3. What is the total value?
2/3.
0.
Yeah, 0. See, so this is what we call as orthogonal. So when you add the coefficient of all, it should be 0. How this coefficient comes? Because you see 1 over 2, 1 over 3, 1 over 3, 1 over 3. So this is plus, this is minus. Or we can say other way. That is also possible. It is same thing. This is also possible, isn't it? Giving minus and plus, it's up to us. Because this is again the same group. They are in one group. These three are in one group. So here they are given plus value. Here they have given minus value. So if you add the value, what is the value now? Adding all the coefficients will be equal to again 0. No differences. So we can have any format as we like. So this is one important factor. Write down. When you add the coefficient, it should be equal to 0. It should be equal to 0. Right? Clear? Right. Now, my objective is, second objective is, I want to compare V1 versus V2. My second objective is, I want to compare V1 versus V2. What are these V1 and V2? What are these V1 and V2?
Old varieties.
Yeah, V1 and V2 are old improved variety. So if I want to compare V1 versus V2, how we can tell in text form, how we can tell in normal form? I want to compare which old improved variety is performing well. I'm going to compare, I have two old improved variety. I'm going to compare which old improved variety is going to be performing well. So that is my objective. So this is also possible. Even though we said the orthogonal comparison is made for group comparison, as the second objective, that is also possible. Look at, if I want to put the coefficient for the second contrast, this is called as second contrast, I will put it as C2, contrast number 2. Second contrast, how I can put the coefficient? Tell me. So this is, I just keep it as it is. Huh? It's easy for you all. So can you tell me how I can put the contrast? What is the coefficient for V1, V2? Anyone? V1? What is the coefficient? Earlier for V1 it is half. What is the coefficient now? One minus one. What about V3, V4, V5? Are they coming into picture in the second contrast? V3, V4, V5? No, they are not coming into the second contrast, so their coefficient values are 0. So that is second contrast. That is called as second contrast. In the first contrast, I am comparing V1, V2 versus V3, V4, V5. In the second contrast, I am comparing V1 versus V2. Right. Now, look at the addition of the coefficient here. What is the answer?
0.
0. Right. When you have one contrast, it is not a problem. When you have two contrasts, look at the board very carefully. Look at the board very carefully. Multiplication of these contrasts. Sorry, coefficients. Multiplication of this coefficient. Multiplication of these coefficients. Multiplication. Multiplication. Then you add all the values. What is the multiplication of this? Half into 1 is? Half into 1 is?
Half.
Half. Half into minus 1 is?
Minus half.
Minus half. 1/3 into C? 0?
0.
0. 1/3 into
0.
1/3 into 0 is again 0. Now add all these coefficient values. Now what is the value? Add all the coefficient values. We are talking about only coefficient. What is the coefficient value? Adding. What is the addition of coefficient value? Add these values.
0.
Minus half.
0.
0. 0. You see, this is the speciality of orthogonal contrast. So we'll have to have contrast in such a way it should be orthogonal. If you add all these values, or if you multiply the coefficients, multiplying, not adding, multiplying the coefficient, at last you can add the coefficients, which is also equal to 0. Clear? Right. This is what I am going to talk about. So this is called as the summation of AI into yi bar. Right. Apart from the simple comparison, one might want to perform the group comparison. Now I am taking an example A, B, C, D, E. All right. So I have A, B, C, D. I have 4 treatment. Just a second, I will make a copy of this and then explain it. Right, A versus B, C, D. A versus B, C. I have 4 treatment, A, B, C, D. So my question is A versus B, C, D. So when you have the average of that, you'll have to divide by 3 because we are adding 3 components. Okay. So here in contrast 1, I can put A is 1 coefficient, B is minus 1/3, C is minus 1/3, D is minus 1/3. If I put coefficient like this, instead of this, I put 3, minus 1, minus 1, minus 1. Is there a difference between these 3, these 2? I have put coefficient 1 minus 1/3, minus 1/3, minus 1/3 in one instant. Similarly, I can put the same as 3, minus 1, minus 1, minus 1 also. Is there a difference between this and this? No difference at all. Why? I have multiplied the whole coefficient by 3. If you multiply this by 3, if you multiply this by 3, if you multiply this by 3, if you multiply this. So we can write either this way or this way. Both ways are correct. Is it clear? Right. Both ways are correct. So this is my first contrast as an example for the given work. Right. So I have given the contrast, the first set of contrast. You see, I have given the first set of contrast. Then, in the second instant, I am comparing C versus D. So I am comparing C versus D. So when you say I am comparing C versus D, C is 1, D is minus 1. C versus D. So A will have a value 0, B also will have a value 0. This is my second contrast. This is my second contrast. A will have value 0, B also will have value 0. And B is not involved. And B is not involved. Right? A and B is not involving, so that C will have a value. Right, now what is the addition of coefficient here? What is the addition of coefficient here? This plus, this plus, this plus, this. What is the addition of coefficient there?
0.
What is the addition of coefficient here? That is also 0. What is the multiplication of coefficient? These are 0, 0, no problem. What about this? 1 over minus 1/3. This is plus 1/3. So if you add these coefficients after multiplication, again it is 0. You see? So this is called as orthogonal comparison. This is what called as orthogonal comparison, right? Right. So these two comparisons you see here, we have two comparison. This is one set of comparison. This is another set of comparison. If you multiply those two coefficients, they are orthogonal. The results from these two comparisons will independent of each other. So that is the important. They are independent of each other. For instance, suppose fertilizer trial consists of 3 treatments. The first treatment is the control and the other 2 are 2 different fertilizer mixtures. In this experiment, one of the information research seeks would be the effect of adding fertilizer for a given situation. So the researcher needs to find out whether applying fertilizer will benefit. In other words, comparison of treatment 1 versus the average of treatment 2 and 3. So that means 1, there is no fertilizer, 2 and 3 with some kind of different mixture of fertilizer. So we want to compare these 1 versus 2 and 3. So in other terms, this is how we write it, 1 versus 2 and 3. Right? So 1 is the mean value of first treatment, that is y1 bar. Then the mean of the second and the average mean of the second and the third treatment, that is y2 bar and y3 bar. So that is this is actually y1 bar minus y2 bar plus y3 bar divided by 2. So if you take the bracket out, so this becomes as minus. That is how it becomes as minus. Okay. Right. We will move to the other slide. Of the form defined earlier, the coefficient of the 3 treatments for the contrast are, so here for this example, we can write it as the contrast. This is A, right? This is A for first treatment. This is second treatment. This is third treatment. So we compare A versus the first treatment versus the rest. So they are getting 1 minus 2 minus half minus half. Or as I said earlier, we can multiply by 2 here. If you multiply by 2, the whole coefficient, you will get a result like this. 2 minus 1 minus 1. All right. Another obvious comparison would be, in this example, the difference between treatment 2 and treatment 3. It is the comparison between 2 mixtures, 2 fertilizer mixtures, 2 versus 3. So we can write that 2 versus 3, where A is not involving with any comparison. So A become the coefficient of A becomes 0. For the coefficient of B is +1. The coefficient of C or third treatment -1. All right. When performing comparison, sometimes a certain comparison become redundant. So redundant comparison can be avoided by performing orthogonal contrast. So orthogonal contrast, this is what I said, when you multiply the coefficients, as I said there, the addition of multiplication of coefficients should be equal to 0 at the end. Here is the AI, and AI are the coefficient of ith treatment from 2 contrasts. If 2 contrasts above are considered, then this is what I said in earlier example. In earlier example, we have 2 minus 1 minus 1, right? You can write it as the contrast of earlier 2 for first treatment, second treatment, third treatment. For first treatment, we have 2. Second treatment -1. This is the first contrast. Third treatment is -1. So this is contrast 1. Contrast 2, 0, 1, and -1. From the earlier example, previous example. So now we, as we did for the others, we are multiplying this. 2 into 0, -1 into 1, and -1 into -1. So if you multiply and add all these values, it will be equal to 0, right? So this is what we call as these contrasts are orthogonal to each other, right? In this case, how many treatments do we have? In this example, how many treatments do we have? We have 3 treatments. 1, 2, 3. If you have 3 treatments, how many contrasts do we have in this example? C1 and C2. We have 2 contrasts. So for a 3 treatment case, maximum we can have only 2 contrasts, which are independent. These 2 contrasts are independent. So this is what it shows, the independency, right? So for a 3 treatment case, we can have maximum 2 contrasts. So how we can say, if we have T number of treatment, the maximum number of contrasts that we can have is T minus 1, right? If we have 5 treatment, the maximum number of contrasts that we can have is 5 minus 1, which is 4. Clear? Right. Thus, for a given number of treatment, the number of orthogonal contrast is fixed. Thus, an orthogonal set can be defined. If the number of treatments being used is T, then the maximum number of orthogonal contrasts possible for a given orthogonal set is T minus 1. This is what I said. So the maximum number of contrasts that we can form is T minus 1, which is equal to the degrees of freedom of the treatment in Anova table. Can you remember, in Anova table, it is the same as the degrees of freedom. However, it may be possible to have several orthogonal sets. We can have several orthogonal sets, right? For instance, for 5 treatment situation, this is set 1. Carefully look at it. So this is set 1, right? Why we call it as this is set 1? Multiply these two. What is the value? 4, 0 is 0. Minus 1 into 3 is minus 3. Minus 1 into minus 1 is 1. Minus 1 into minus 1 is again 1. Minus 1 into minus 1 is again 1. So add all these values. What is the answer? If you add all these values, it will be equal to 0. Right. That is, you have how many treatments? 5 treatments. You have 5 contrasts. This is first contrast, this is second, third, and this is fourth. Right. Now, the multiplication can be with other contrast also. Look at 4 into 0, 0. Minus 1 into 0 is 0. Minus 1 into 2 is minus 2. Minus 1 into minus 1 is plus 1. Minus 1 into minus 1, again plus 1. So what is the addition of all these contrasts? Multiplication of contrast. Again, it is 0. So likewise, you can write down the contrast for any combination. Look at this combination. Calculate in similar way. Look at for this combination. Calculate separately. And see whether we are satisfying the rules of the coefficients. Multiply these two compounds and see individually. multiply this compound and see whether it is satisfying the rule. So it should satisfy the rule. Otherwise, they are not independent contrast, right? Otherwise, they are not independent contrast. All right. So this is one set. Any questions? Any questions? But these contrasts are coming with the objective. What sort of objective that we should have? So based on the objective only, we can formulate the contrast. But we'll have to make sure that these contrasts are orthogonal. Otherwise, you cannot continue. Right. Look at another set of contrast. So this is not same as this. So this is set 1, right? This is set 1. This is set 2. Maybe the first contrast is same in this example. But look at second. Is this second is same with the second here? No, it is different. So here tell me, this is 1 versus the rest. Right, in this case 1 versus rest, 2 versus 3, 4, 5, isn't it? This is 3 versus 4 and 5. This is 4 versus 5, isn't it? In this case, this is 1 versus the rest. This is 2 and 3 versus 4 and 5. See, this is different from this, isn't it? Then the next one is 2 versus 3. The next one is 4 versus 5. You see, totally different sets of objective or contrast. So again, cross-check, multiply the coefficients individually for all contrasts, C1 versus C2 or C1 versus C3. Multiply and see all the coefficients. You will see all are equal to C. Any questions? Any questions? Yeah. Anyone would like to ask questions? Any questions? Right. Then we will look at the concept of this contrast, which I have already mentioned. Summation of the multiplication of coefficients, whereas it should be equal to 0. So this is the mean value. We will see with an example how to calculate the contrast and so on, right? And let Qi is the treatment total. It is the treatment total, Qi, okay? And how to count the sums of square, how to calculate the sums of square. Let's look at that. So this is the formula to calculate the sums of square of a contrast, right? If you look at the Anova table, can you remember the Anova table? Source of variance, degrees of freedom, sums of square, mean square, and the F calculated value. Let's take, I have a 4 treatment. I have 4 treatment. Let's say CI. Anova table, how the Anova table looks like? Source of variance, degrees of freedom, sums of square, mean square, and so on, right? So if I have CRD, this is treatment. How many degrees of freedom? If I have 4 treatments, T minus 1, that is 3. So here I have error degrees of freedom, error sums of scale as a source of variance error and the total source of variance. CRD with, let's say, 4 replicates. 4 replicates. So the total degrees of freedom is 15. T into R minus 1, that is 12. Error degrees of freedom is 12. Now we said if we have 4 treatments, T1, T2, T3, T4, if you have 4 treatments, we can maximum develop how many contrasts? We can maximum develop 3 contrasts, T minus 1. So here 4 minus 1, we can develop only 3 contrasts. So if you can develop 3 contrasts, C1, C2, C3. We can develop in this example only 3 contrasts because there are 4 treatments. So their degrees of freedom is 1 each. So if you add all these degrees of freedom of contrast, that is equal to 3. Okay? So addition of this. Let's say if you have sums of scale X for treatment, Y1 is the sums of scale for contrast 1, Y2 is the sums of scale for contrast 2, and Y3 is the sums of scale for contrast 3. If you add all these sums of scale, it is equal to X. Clear? So this is the sums of scale of contrast 1, sums of scale of contrast 2, sums of scale of contrast 3. If you add, that is equal to the treatment sums of scale. Similarly, we can talk about mean square of contrast. Mean square of contrast is same as sums of scale. Why? Because their degrees of freedom for each contrast is 1. So dividing sums of scale by 1 will give the same mean square as the sums of scale. No difference at all. Okay. Right. So how to calculate the sums of scale? This is given there. So this is, we can use the formula. So Q, I mean it is the treatment total. So can you remember in earlier case we calculated all the treatment total? This is the coefficient, right? This is the replicate. This is the coefficient square. We'll take an example and try to see. Since the degrees of freedom for each contrast is 1, the mean square for contrast is same as sums of scale contrast, as I pointed out earlier. With the mean square for the contrast can be tested as mean square of contrast divided by mean square of error. So we always testing F-test using mean square of contrast divided by mean square of error. Provided an F-test, if the F calculated value is greater than the table value, then the contrast is significant. So that is how we make the decision. Right. Now we have come to an example. 4 varieties are there, right? How many contrasts that we can formulate? We can formulate, this is contrast 1, this is contrast 2, this is contrast 3. We can formulate only maximum 3 contrasts. So V1 versus rest, so 3 versus rest. V2 versus V3 and 4, so V2 versus 3 and 4. And the last one is V3 versus V4. So you multiply and see, all are giving 0 values. multiply and see all the coefficients, you will get the 0 value, right? You can check and see. This is already worked example. This is how you can formulate the contrast. This is output from the SAS, right? As an example, just to show you, you see here V1 versus rest. That is the source of variance. You have 1 degrees of freedom. The sums of square is that. Mean square is also same because only 1 degrees of freedom. Here V2, V3 versus V4. Here mean square, sorry, sums of square, mean square is same. Then we can calculate the F value. The error degrees, error sums of square is not given there. So it is partially taken from table. So here this is F value. This is another F value for contrast 2. This is the F value for contrast 3. Based on that, we can see whether it is significant or not. Right? This way of interpretation you will get to know once you do the practical. According to the alpha, we can say it is significant. Normally, we compare with the alpha, the ultimate value. We compare with the alpha whether this given value is greater than alpha or less than alpha. If this value is less than alpha, then we can say it is significant. This is significant, this is also significant, this is also significant. So V1 is different from the rest of the variety. So V1 is different from the rest of the variety. V2 is different from V3 and 4. Right? So variety V2 is different from both V3 and V4 because it is significant. Similarly, V3 and V4 are different. V3 and V4 are different, as an example. So this is an example. Huh? Don't worry about this example, but just to show you how to interpret this. This you will learn more on practical aspects. Right. So this is just a calculation for the contrast, right? Calculation for the contrast. Let's say if you want to calculate for a contrast. So these are the mean value of first treatment, mean value of second treatment, mean value third, and so on. So these are the coefficients, right? Into their mean values. So 3 into 45.5 and so on. This is how you calculate the what do you call each contrast. So this is the contrast 1 and contrast 2 and so on. Depends on what coefficient values that you have. Right. This is another example. This is what I said already. I have 4 treatment, A1, A2, A3, A4. Now I have this first contrast, second contrast, third contrast. So here I am comparing A1 plus A2 versus A3, A4. So this is how we write half, half, minus half, minus half. Then here what I compare is A1 plus A3 versus A2 plus A4. Second contrast. The last contrast is A1 plus A4, A1 plus A4, right? Versus A2 and A3. Clear? Right. Now, after putting all these contrasts, you can multiply their coefficient, right? So in the second step, we are multiplying the coefficient. So we are multiplying the coefficient L1 into L2. So multiply this. If you multiply, that is 1 over 4. If you multiply this, that is minus 1 over 4. If you multiply this, again, that is minus 1 over, sorry, minus 1 over 4 again. So multiply this is become as plus 1 over 4. So the summation of the coefficient is 0. So likewise, you can multiply and see L1 into L3, L2 into L3. All are orthogonal. So this is what all possible multiplication should be done to see whether all are 0. I will continue because I will finish in another half an hour maximum, so that I will continue, right? Without break. The three mutual orthogonal contrast are there. Mutual orthogonal contrast. So their sums of squares are given there as an example. Sums of square or mean square is same. Second one is third one as an example, right? So if you add all these sums of squares, as I pointed out earlier, it should be equal to the sums of square of treatment. Okay. Right. We have the exercise. This is the exercise actually. How many treatments are there? T1, T2, T3, T4. Four treatments are there. What are the speciality of this treatment? Look at this treatment carefully. T1 is control. T2 is single dose of nitrogen. T3 is double dose of nitrogen. T4 is applying potassium fertilizer. So four different treatment. Their treatment means are given here. Already calculated treatment means, and the grand total of each treatment. This is for the treatment 1, treatment 2, treatment 3, and treatment 4. These are the mean values of each treatment. Assume that all of them are having 4 replicate. Actually, it is a RCBD design. Residual mean square is assume this is as a 57 residual mean square. MSE, residual mean square. Now my contrast is, first contrast is fertilizer versus control. So if it is fertilizer versus control, what versus what? T1 versus, right, rest. So fertilizer versus control means T1 is the control, T2, T3, T4, all these are with fertilizer. So fertilizer with control, sorry, fertilizer with control. So T1 versus rest. Then you are comparing only within nitrogen, single dose versus double dose. So that means T2 versus T3. I'm considering only T2 and T3. The last one, effect of K, we compare T2 plus T3 versus T4, because we want to see the effect of K. That means we'll have to compare whether this K is better than N. Could be single dose or double dose, the average of N. Right? So this is my contrast. So the same contrast have been appeared here, right? T1 versus T2, T3, T4, as I said earlier. Then T2 versus T3, T2 plus T3 versus T4. We can write down the coefficients of this contrast. This is -1, this is 1/3, 1/3, 1/3 plus. T2 versus T3, this is +1, this is -1. Then T2 plus T3 versus T4. So this is half, half, and -1. Multiply all these individuals or multiply all these coefficients, it will be equal to 0. If you add all the coefficients, it will be equal to 0. Right, now most important is how to calculate the contrast. How to calculate the contrast. Residual degrees of freedom is, it is a RCBD. So T into R minus 1, right, or T into B minus 1. So that is 3 into 3, 9 is the residual degrees of freedom. for each contrast, we can calculate the sum square. So this is the formula, as I said. If you want to calculate the sum square for first contrast, it is the coefficients. These are the coefficients, right? Minus 1 into treatment total of first treatment total, plus 1/3 is the coefficient into the second treatment total, plus 1/3, it is the coefficient into third treatment total, which is 144. 1/3 into 180, it is the treatment total of fourth treatment. Whole thing square divided by R. R is the number of replicate, number of blocks actually. Summation of square of all the coefficients. So -1 square plus 1/3 square plus 1/3 square plus 1/3 square. So if you get all these sorted out, you will get a value 507. Similarly, you can calculate for sum square of second contrast. All right, only the coefficient changes. The treatment total remain as it is, right? Coefficient changes, so you get the sum square for the second contrast. Then you calculate the contrast for the third sum square, which is again the contrast sum square. When you calculate the contrast sum square, the treatment total remains same. Only difference is you change the coefficient values based on what contrast are you talking about. So here it is 294. So add all these three contrast value, right? This is the first sum square, second sum square, and third sum square. If you add all these sum square value, it is equal to the treatment sum square value. We calculate the F value. To calculate the F value, we need to have degrees of freedom of this. We need to have degrees of freedom of that. What is the degree of freedom of error? Error is 57. Error mean square is 57. Error degrees of freedom is 9. We have already calculated. What is the degrees of freedom of the first contrast? This is 1. So we can look at the table and see whether it is significant. These values are significant. This is not significant actually because the value is very low. This may be significant. This may be significant. Depend on what table values. Right. That's all about the mean separation. Because we talk about different types of mean separation. First, individual comparison of mean separation. Then we discuss about the mean separation on right. Any questions? Any questions? Do you have any questions? Maybe I will see whether I can upload all these documents into YouTube. If possible, I will upload it. I hope all of you have a copy of this lectures, right? Do you have?